Suppose we have this function here, y equals x multiplied by 2x cubed plus 10x raised to the power of 100. Now, of course, we could use the binomial theorem and expand this thing out. That would take a long time, of course. We would actually have 101 terms if we were to expand this out by the binomial theorem. And with those, we'd have to multiply all those terms by x and then differentiate term by term. You know, that's not practical, so we use something called the product rule. So I'll just explain what to do and then I'll prove the product rule. So we have a product of two functions here. Actually, we could write this as u of x times v of x. The x in brackets indicates that the independent variable is x. So one of the functions is called u and the other one is called v. Then the derivative dy dx is the first function u times the derivative of the second function, that's dv dx, plus the second function v times the derivative of the first function, du dx. Okay, so I left off the x in brackets. The x in brackets just indicates that u is a function of x. Similarly for v. So u is one of the functions and v is the other function, and we have a product. We're multiplying two functions together. So we could let u equal, say, the first function and v equal the second function, but it doesn't matter, of course, which way we do it because we're multiplying. So we can let u equal x and v equal 2x cubed plus 10x to the power of 100. So if we want to get the derivative, we write down u, which is x times dv dx. That means we have to differentiate 2x cubed plus 10x to the power of 100. So I'll write that over here. V equals 2x cubed plus 10x to the power of 100. Now, in the last video, I explained how to use the chain rule to differentiate such a thing. So what you do is, well, we can't expand it out, so we have to use the chain rule. We bring 100 down and subtract 1 from 100, which is 99. So differentiate around the brackets, you could think of it like that. And then multiply all of this by the derivative of what's inside the bracket. So we have to differentiate what's inside the bracket with respect to x. So if we differentiate 2x cubed plus 10x, we get 6x plus 10. And we tidy it up, that means we multiply 100 by 6x plus 10. So we get 600x plus 100 times 10 is 1000. And that's multiplied by 2x cubed plus 10x all to the power of 99. Of course, we don't expand this out. And we certainly don't multiply 600x plus 1000 into this. We'd have to expand the second brackets out first, which we don't do, of course. By the way, this here should be 6x squared. The derivative of 2x cubed plus 10x is 6x squared plus 10. So we have u times dv dx. So I've just written down dv dx. I've just copied this down. Then we have plus v. Well, v is the second function, which is 2x cubed plus 10x to the power of 100. And that's multiplied by du dx. U is equal to x. When we differentiate x with respect to x, we get 1. Now I'm not going to bother simplifying this. The next thing I want to do is prove the product rule. Here we have that y is a function of x, and it can be written as a product of two functions. The first function is called u, which of course is a function of x, and the second function is called v, which is a function of x. So these are multiplied together. So to get dy dx, or f prime of x, we can call this f of x, we have to calculate Newton's quotient. We have to calculate the limit as h tends towards 0 of Newton's quotient, I should say. Newton's quotient is f of x plus h minus f of x divided by h. So what is f of x plus h? Well, we just replace x with x plus h. So this thing becomes the limit as h tends towards 0. Replacing x with x plus h gives us u of x plus h multiplied by v of x plus h. So that's f of x plus h. We just replace x with x plus h. This is of course an abstract situation. In previous videos, u was some specific function and so was v. It's the same idea. If we knew what u and v were, we'd plug x plus h in for x in both functions. Then we subtract f of x. Well, that's just u of x times v of x. And we divide all of this by h. Now remember, our answer is v times du dx plus u times dv dx. This thing is listed in tables. This is dy dx, where y is a product of two functions u and v. So what you'll be trying to do is work du dx into this. Du dx is actually the limit as h tends towards 0 of this quotient here. This is just Newton's quotient applied to the function u. If we apply it to the function f, we have f of x plus h minus f of x over h. So to the function u, we just replace f with u. So we want v times du dx. So what you will need to do is somehow bring in this quotient. And also we'll have u times dv dx. So this quotient here, v of x plus h minus v of x over h, is just Newton's quotient applied to the function h. So in order to get that to work, we had to add in a few new terms. You can see that u of x plus h times v of x plus h appears here. When we multiply these, we get these two terms. But now we have a new term coming in. We have minus u of x. That's new. Okay, so we have to put in this to get Newton's quotient applied to the function u. So that gives us v of x plus h times u of x. Or actually minus v of x plus h times u of x. That doesn't appear in this. So we have to compensate by having it here. U of x here multiplied by plus v of x plus h. Alright, so v of x plus h times minus u of x will then cancel with u of x times v of x plus h. They must cancel out. So by putting it in here with a minus sign, we have to have it again with a plus sign, so that everything highlighted here in blue will cancel out. So that v of x plus h times minus u of x cancels with plus u of x times v of x plus h, so that we get, we haven't changed anything. Of course, we also have plus u of x times minus v of x. That gives us this term here. And of course, when we multiply these two, we get this. So, these are identical. The next thing we do is bring in Newton's quotient. So what we do is we factorize this. Well, actually, we don't factorize it. We write it as two fractions. So we split it into two fractions, and we just factorize v of x plus h out of side this. So we put h under both terms here, and we factorize ux out of the second term, so we get Newton's quotient applied to the function v. And now it's in this form that we're aiming for. We just, the next step is just to take the limit as h tends towards 0. So we're getting the limit as h tends towards 0 of this thing, and of course we're doing the same here, getting the limit as h tends towards 0. And what happens? Well, if h tends towards 0, what happens to this? Well, x plus h will just tend towards x, so we just get v of x. But when we take limit as h tends towards 0 of this here, this is Newton's quotient applied to u, so the limit will give us the derivative of u with respect to x. We could write it like this, u dash x, or we could write it as du dx. V of x just means v. We can actually just drop this. V is a function of x. We can just write v. That's when h goes to 0 here. And over here then we have plus u of x. We can just write u times the limit as h tends towards 0 of this thing here, which is Newton's quotient applied to v. Well, that gives us dv dx. So that's the product rule. So dy dx is v du dx plus u dv dx. Now, I want to consider a function that's a quotient of two functions. A quotient is just means a fraction. a fraction that cannot actually be broken down. We can't easily divide x squared by 2x plus 3. We can't get this into the form of a polynomial and then differentiate term by term. We can't do that. So there's a special rule called the quotient rule. The function on top, or the numerator, is called u, and the denominator is called v. Now what we call u and v is important here. We must call the numerator u, and we must call the denominator v. Because when we're dividing, the order of division matters, of course. We can't say u over v equals v over u. Anyway, I'll just state the quotient rule. dy dx equals v du dx minus u times dv dx, whole lot divided by v squared. So if we want to apply it here, we see that v is 2x plus 3, and we multiply by du dx. We differentiate x squared with respect to x, that gives 2x. Then we have a minus sign. Then we have u, which is the numerator, x squared, times the derivative of the denominator, dv dx is 2. And all of this is divided by v squared. That's the denominator squared. And we could simplify out the numerator, so we get 2x by 2x is 4x squared, and we have a minus 2x squared here. 4x squared minus 2x squared is 2x squared. And then we have 2x by 3 is plus 6x. And that's divided by 2x plus 3 all squared. Now to prove the quotient rule, we could just use Newton's quotient. You know, we could go through first principles. We could get f of x plus h minus f of x divided by h. Apply it here. We'd have u of x plus h over v of x plus h. Okay, so this is f of x. F of x equals u of x over v of x. U on top. F of x plus h is got by just replacing x with x plus h. So we'd have u of x plus h divided by v of x plus h minus f of x, which is u of x over v of x divided by h. And we'd have quite a complicated limit to deal with. We have to take the limit as h tends towards 0, and we have to use a trick, not so easy to figure out or remember for that matter. So I'm going to do this in an easier way. I'm going to use the product rule to prove the quotient rule. So to use the product rule to prove the quotient rule, we just rewrite y equals u over v as u equals v times y. Okay, we just cross multiply, and we differentiate both sides. So we differentiate the left with respect to x, get du dx equals, and when we differentiate the right hand side with respect to x, we use the product rule, because we have a product of two functions here. So the first function, we call it u, and the second function we call it v. This u has nothing to do with this u, of course, but of course we know what the rule is. It's u times dv dx plus v times du dx. That's the derivative of a product of two functions u and v. The first function times the derivative of the second function, plus the second function times the derivative of the first function. So I don't want to be writing u's here, because this u is not the same as this u, of course. U just indicates the first function in the product. V indicates the second function in the product. So in words, we take the first function, which is v, times the derivative of the second function. So we differentiate y with respect to x. Then we take the second function, which is y, times the derivative of the first function with respect to x. That's dv dx. Now what we're looking for is dy dx. That's the derivative of this quotient. So we have to isolate dy dx. So we bring y times dv dx over. I'll turn this around actually. I'll write this on the left. That's v dy dx. I'll write that on the left. And we bring that term over. And I'm going to write what we get on the other side on the right. That's du dx minus y times dv dx. So the y dv dx is brought over, it changes to minus y dv dx, and we add it onto du dx. And then we want dy dx, so we just divide across by v. Dy dx equals this thing divided by v. Okay, I can just write it as 1 over v du dx minus y over v times dv dx. But we have y in here, And we know that y is just u over v, so I'm going to replace y here with u over v. So this is u over v. U over v divided by v, that's the same as u over v times 1 over v, or u over v squared. So we get u over v squared. Okay, the next thing now I want to do is multiply above and below by v squared. We can think of this thing as being all over 1. So if I multiply the top by v squared and the bottom by v squared, I'll get the result. So we'll have v squared times 1 over v. V squared over v is just v. So we get v times du dx. V squared times minus u over v squared gives us minus u times dv dx. And we have v squared times 1 is v squared. So here's the formula for the quotient rule. The derivative of y equals u over v is v du dx minus u dv dx all over v squared.